or simultaneous equations involving fractions. Today we want to look at the ones that involve quadratic equations and then how best we can talk about the equations as well. Quadratic equations as well. Yes, so we are exploring the simultaneous equations that involve the quadratics. Now, when you have a simultaneous equation and then you realize that one of the involving equations is being operated upon by multiplication, then definitely you are going to have a situation where you need to do substitution in the other equation, be it equation 2 or equation 3, in the other equation, and then from there you come and substitute that. You make the one variable the subject in the previous equation, then you come and substitute it in the equation that is having the multiplication, and when you do it like that, at the end of the day you are going to end up having a quadratic. And then how do you go about the quadratic? That is what we want to explore today. So let's take a question and then let's see how best we can talk about that. After that, I give you one or two assignments. You try your best. Whatever you get, you put it down. I will also try to provide you with some of the answers so that when you are working, you are guided by the solution so that you know whether or not you have got the right option or you've got the wrong one. When you get it wrong, it doesn't mean that you are not good. It simply means that you need to take your time and then do it better. That's all. No one is perfect. Okay, so no one is perfect. So we need to take our time in judging people. So you relax and then try it again. All right. Okay, so let's take the questions quickly. So when we observe this question carefully, equation 1 contains xy is equal to 12, and the operation over here is multiplication. Equation 2 says that x plus y is equal to 7. Now we see that equation 1 and 2 are not the same because one has been operated upon by multiplication and the other is just the normal addition operation. So what do? We now have to focus on the equation 2. So you say that focus on your equation 2. So from equation 2, when we make x the subject, we are getting x is equal to 7 minus y. We can call this equation 3. Then you can now come and put equation 3 into equation 1. Please, you can make y the subject from equation 2. You can make x the subject. It is not objective that you make x the subject. You can decide to make y the subject. It is still correct. Okay. So we put equation 3 to equation 1. Then we have 7 minus y times y is equal to 12. 7 times y, that should give us 7y. Y times y squared. Now we are having a quadratic. So we have to make sure that it is of the form ax squared plus bx plus c is equal to 0. Better so we can bring the 12 to this side so that we have everything in terms of all the terms being on one side and then 0 at the other side. We can send the y squared to this side so that it becomes positive, just for us to be able to work with the positives well. So I have 0 is equal to 12 plus y squared minus 7y. I rearrange it, I get y squared minus 7y plus 12 is equal to 0. Now this we can use our completing of squares. We can use the factorization to solve for the value of y. But for the time being, I would like us to work with the factorization so that when we get to the quadratic equations itself, I will take you through the completing of the squares method as well. Or better, so you can use your almighty formula, which is the quadratic formula, to get the value of y. But for now, let's look at the factorization. So the factorization says that when you compare this with ax squared plus bx plus c is equal to 0. Better still, I want to replace the x with y so that you get the picture clearly. When I compare this, I can see y squared, I can see y squared, I can see y, I can see y, I can see c, I can see c, I can see 0, 0, equal to. What will be the coefficient of y over here? The coefficient of y here is 1. So I can say a is equal to 1, my b is equal to negative 7 and not 7. B is equal to negative 7 and then c is equal to 12. Okay. If you want to use the factorization method, multiply a with c. That will give you 1 times 12. That is 12. And then you find the factors of 12 such that when you multiply, you get 12, but when you add, you get the minus 7 over here. And what are the factors? Remember, the factors of 12 over here are going to be positive and negative whole numbers. Positive and negative whole numbers. So I take these factors of 12. I have plus or minus 1 against 12 itself. And then I have 2 against 6. And I have 3 against 4. Now 1 times 12, 12. 2 times 6, 12. 3 times 4, 12. I can pair the numbers all in terms of plus or minus. Now when I multiply all this, 1 by 12, 2 by this, I get 12. But which of them is such that when I add, I'll be able to get negative 7. I add, if here is negative 1, here is positive 12. When I add these two, I'm not going to get negative 7. Let's see, here is negative 2, here is positive 6. When you add, you get no. Negative 2, negative 6. When you add, you get negative 8. When you multiply, you get positive 12. Which means that the answer lies in this particular bracket, which is 3, 4. When I multiply negative 3 by negative 4, I get positive 12. Negative times negative, positive. And then also, when I add negative 3 to negative 4, I get negative 7. So in place of this negative 7, I'm going to split it. Y squared minus 4y minus 3y plus 12 is equal to 0. This negative 7 has been splitted, and that is what is given as the minus 4y minus 3y. Now I can now factor this ones like this. What is common to y squared and y? 4y, that is y minus 4. What is common to 3 and 12? That is 3, y minus 12 and 4 here. I put this also in bracket. This is common, so I pick the common one first, then I put the outer ones also in one bracket. Now what you see over here is multiplication. It means a number times another number is equal to 0. When you have two non-zero digits and you multiply, there's no way you're going to get 0. Unless, of course, one of the numbers is 0. So how do we prove that? It is either this is the one equal to 0, which means y is equal to 4, or y minus 3 is equal to 0, y is equal to 3. I've gotten two values for y. Then it means I have to get two values for x as well. Remember we said x is equal to 7 minus y. When y is equal to 3, then x is equal to 7 minus 3, which is equal to 4. When y is equal to 4, x is equal to 7 minus 4, which is also equal to 3. So therefore, I have my values in this form, x, y, giving me the first pair. So the first pair is going to be when x is equal to 3, y is equal to 4. Second one, when x is equal to 4, y is also equal to 3. So I have it in this nice form. That is it for the quadratics. So I'm going to give you two exercises or assignments, and then I'll give you the answer for either one or the two of them, so that you can work towards that answer. Okay. So for this one, x, y will be equal to, so I have 0 for x and then y for 1, and then 2 for x and 3 for y. I've given you the option for this. So you find the answers to the first one. Thank you very much. Please make sure you subscribe so that you can